Welcome to TCT 2019. This is kind of a weird show that doesn't really know what it wants to be, whether it's a purely B2B, an industrial show, or whether smaller companies like E3D, Duet, 3D, Prusa, etc. are welcome here too. But I found some nuggets in this, kind of unique place that I'm in. We're talking about extruders, we're talking about PVC materials. We've got one of the craziest printers that I've ever seen. Not sure if you can see that behind me. And I've also got news from Ultimaker. They've released a few new things on this show. And I can be here thanks to the sponsorship from Duet 3D. The Duet 2 and the low-cost Duet Maestro mainboards are already some of the best mainboards you can use for your 3D printer or CNC machine. And the new Duet 3 is about to launch as well. It comes with all the features you're used to from the Duet series of boards and now has more expandability than you'll ever need. Check it out at the link below. But let's start right over here at E3D. All right, Sanjay, this is the Hermes. Is this launched yet?
No. It's in manufacture now. It's scale up time. So
it's announced, right? People cannot When can people order it?
they'll be able to order it when it's ready to ship. We don't want to get into like a big pre-order backlog.
That's a good approach. I know some companies who've missed that mark.
Exactly. Yeah, try not to tie ourselves up in knots.
So what is this? This looks like a Titan Aero extruder hotend combo, but done better.
Yeah. I suppose the code name for the project was like Aero V2, and then as we got further and further away from what Aero was, it was no longer an iteration, but like total from scratch rewrite. So conceptually the same, complete extrusion system with hotend and fan and all the gears and all the driving stuff. But it's way more integrated. It's a way tighter package. It's easier to use. It costs less than Titan Aero. And it's got dual drive gear performance and just like incredible filament constraint.
So we got the dual drive gears. We've got a 3-to-1 gearing still, I guess?
Correct, yeah. Prime number near enough, 3.
Yeah. Close enough. And it's got no classic V6 heatsink. So can you show us how that works?
Yeah. So this heatsink is kind of inspired by GPU fans where the blade of the fan kicks the air out tangentially. And so if you arrange your fins tangentially, they kind of follow the momentum of the air really efficiently. So that gets us lots of cooling. But then it gets a bit weird because we've got this kind of wall here, and that wall prevents the air from being thrown down towards the print. And so you see a lot of printers out there, you may not have even noticed, but with a V6, the air runs sideways, and when it comes out the other side, there's lots of wash, and it kind of disturbs the printing envelope. And so you can get one-sided warp.
So this all gets kicked upwards?
Yeah, all the air gets thrown out like that, instead of it kind of going down here and adversely cooling your print. You want that very separation of powers, if you like, between your heatsink cooling fan and your print cooling fan, so you have the maximum amount of control.
And there's no option to mount the very, very classic V6 anymore. This is a special heat break that you're using.
Exactly, yeah. So the heat break is smaller. We've gotten better at manufacturing things now, so we can go much closer to the limit. So it's an M4 threaded heat break.
Which, by the way, looks absolutely minuscule and fragile and tiny, but is it?
No, the wall thickness is actually, up in the M4 section is way thicker than a normal heat break is in its thin section. So really not delicate at all. But yeah, it's normal V6 type components down here, so it's compatible with all your heater cartridges, nozzles, Volcano Super, all that whole trifecta is kind of bolt straight on.
Yeah, and it's always going to be a set of the Hermes extruder body plus your stepper on the back. And this is not a traditional NEMA 17, right?
No, it's a very special NEMA 17. So the idea here was that NEMA 17s have a lot of kind of wasted space in them. And the faceplate, we were basically going to cast a machine and put a metal body on the front of a NEMA 17 and then put the lid on top of that, and that be our product. And then
so it's redundancy, right?
Precisely, it's redundancy. We just agglomerate those two components, and once you start making them yourselves, you get a whole bunch of other benefits as well. So we can put these T-slots in the side for mounting nuts. We can face off the side so you get a true flat, like machine surface to mount with.
So you don't have to do that weird shim thing in the middle of the Titan or Titan Aero where it's like,
Yeah.
You can just straight screw into the side of the Hermes.
Yeah, precisely. So it gets rid of the intermediate, the mounting, the sandwich mount, as we used to call it. You have to sandwich a part of your printer in there, which is nice for a couple of reasons. It simplifies the design of how to get it onto your printer is just obvious, 4 screws. But it also means that we can assemble these and test them and ship them to you as ready-to-go products. Both if you're a printer manufacturer or if you're just a normal customer, you can buy one that's done, ready to go, individually serialized with a QR code, and we'll be trying to do like a Prusament type deal almost. That's the inspiration, where the test data, calibration data, etc., all the data manufacturer, who made your Hermes, is all accessible to the user through a web.
And that small motor has enough force and enough push force with the gearing to actually drive something like the Super Volcano at decent speeds?
Yeah, more than. In fact, this motor's probably over-spec'd. And so I think, in going down in the future, as we optimize this product, many moons away, we'll be able to, really start squeezing the number of laminations, getting that smaller. There's a whole bunch of things that we can do there.
So this one is actually larger than what do you think you need?
Yeah. With the next size down would have been perfectly fine. But a lot of people, tuning stepper drivers is tricky. If you just want to take it straight out of a machine that maybe doesn't have easy to adjust current, for whatever reason, it's got a closed electronics board, but you still want to just plug it straight in. It's got a lot of margin in it. It's got a lot of margin, so you can kind of you don't have to really tweak in the motor currents. If we went with a shorter stack, we'd be relying on the user to get it just right.
So any info on how it compares to the existing Titan or Titan Aero as far as size or weight or overall performance goes?
Yeah. So in terms of I kind of look at it from a bounding box perspective, and Titan Aero has a much larger bounding box to it, and also a much larger just absolute volume if you beyond the bounding box. So you're kind of talking about at least a third in terms of volume removed from the system. But it's still NEMA 17 faceplate compatible. It just lacks a lot of the bulk in both the axial and radial directions.
And any info on price compared to, say, a Titan Aero?
It should be cheaper, which is a cool thing to be able to say. Aero is a fully machined product with a really complex machined heatsink.
We have one right here. Can actually show that. Yes. So that has the tool changer mount on it, and you see the shiny part. Obviously, that is more expensive than just the die-cast part.
Exactly, and the die-cast part's actually higher performance because geometric complexity is free if you're cutting a mold, so we can put in these crazy fins without ever having to worry about the tool pathing for that. We can make much thinner walls than we can by machining, so we can make it a lighter part, whereas the Aerosync has some big chunky hunks of aluminium in there. These is thinned out, shelled out.
Very nice stuff. I have one already. I've had one for a few weeks. So now I guess I can actually start putting it on a machine that I'm going to show to the public. Yeah. Really excited for that. And thanks for showing it off.
No worries. Thank you very much, Tom. It's been good.
Ian, you've brought the XYUVA or CoreXYUVAB printer.
That's the one.
What is this?
What is it? It's evolved over the years into what you see now. It's a CoreXY with a 5-color diamond hotend. That's 5 in and 1 out. I didn't want the extruders on the frame, which would give me huge, great long Bowden tubes. So the extruders are mounted on a second gantry, which means I can have short Bowden tubes.
So that second gantry is also mechanically independent from the actual hot end one.
Correct. It will move completely independently. So when there's no power on the printer, then it could get out of sync with the hot end. So for homing, it becomes a UV gantry. So it's got its own separate switches. So it homes X, Y, U and V independently. Once they've been homed, then the UV motors get mapped to the XY axes, so it becomes, as far as the firmware is concerned, it's just a CoreXY.
But the goal with having two different gantries for the actual hot end and the extruders was to reduce the mass that is actually coupled to that motion system of the extruder, or of the hot end, right?
Yeah, to some extent. Primarily, I didn't want huge, great long Bowden tubes. So the alternative would be to mount the extruders directly on the same carriage. But it's physically big as well as the mass. So it takes up too much, to my mind, too much movement in X and Y. So putting them above gave me more movement. But it also, it's got its own motors. It's completely independent in that respect. But then I did say it kind of evolved into what we have now. So originally it was a 3-color with 3 extruders, which originally I had kind of hanging on a piece of string, and a pulley and a counterweight.
As one does.
Yeah, why not? And then that wasn't terribly successful. So then I mounted them on a gantry like that, but it was passive. So it was just joined to the hot end with basically bits of string, and the hot end dragged it around, which worked quite well with short zigzag infill movements, because the hot end would do that and the extruder would stand still.
It would just start resonating too, right?
But with long, fast, non-print moves, once you get that lot moving, it doesn't want to stop. So it would carry on and it would just snap the pieces of string and so forth. That wasn't very good. So that's when I decided to power the gantry. And then it's kind of evolved a little bit further, because I now move something like 5 kilograms of mass in the Y direction. So the XY is around about 2 kilogram with all the rails, and that's about 3 kilograms, so I add it together. And I do crazy things like set the mixing ratio to 20% for all the extruders. So then you've got 5 melt chambers being fed by 5 extruders, and the filament going through at 1/5 of the speed. So you can print, I have printed at 300 millisecond quite successfully. But when I do crazy things like that, the whole printer tends to rock around a bit, because I've got this 5 kilograms of mass being shoved around. So, and the easy thing would be to kind of bolt it to the wall or bolt it to the floor or something. But where's the fun in that? So I've got a third gantry, which is the AB gantry, and that moves in sync with the other gantries.
But in the exact opposite direction.
Motor directions are reversed. There's a certain amount of mass in there to compensate for the Y, and then a great big lump in there to compensate for that. It's kind of scientifically calculated, but it might not be right. So basically I've got 2 kilograms at about, taking the floor as the pivot point, I've got 2 kilograms at about 1 meter, and then I've got another 3 kilograms at about 1.1 meters. So that's about something, I can't remember the mass, something like about 5.3, 5.4 kilogram meters. And so therefore that's at 1.6 meters, divide 5.4 by 1.6, it gives you the mass, roughly. And it seems to work.
And this entire thing is powered by the Duet 3, right?
Exactly, yeah. It's kind of a bit prototype at the moment in terms of the expansion boards. So they are actually prototype boards, they're not production boards. So I've got a Duet 3 main board, and then 3 expansion boards, and the expansion boards communicate by CAN FD bus. So 2 expansion boards are mounted on the gantry with the extruders, so I've got 3 extruders on each expansion board, and then the hot end heater and the thermistor and the fans and all the other gubbins connected there. And then the 3rd expansion board has got the X, Y and Z motors on. In total there's 13 motors, and Duet 2 only gave me 10 or 12 if I use some external drivers. I've only got 1 Z motor, so it's you're saving motors there. Yeah, exactly. I don't want to go too much over the top. So yeah, the 2 things that for me, Duet 3, I need more than 10 motors for this crazy beast. But the other big thing for me was the simplified wiring, because with Duet 2, everything had to go back to the main board or the Duet X5, which had to be close to it. Because these communicate over CAN bus, the boards can be local to the motors. So when I rewired this, I got about a carrier bag of cable that I'd taken out. I used to have a huge, great cable chain with 40 conductors in it going there, and now I've just got power and data. So it's a huge saving.
It's definitely one crazy machine. Yeah. So thanks for bringing that along.
Built by a crazy old man.
All right. Thanks for your time.
Thanks, Tom.
Start it up.
I'm here with Ed Tyson from formerly Rigid Ink, but now the Institute of 3D Printing. I had to check that again. What happened to Rigid Ink?
So we kind of just stopped selling filament, is the short answer.
Why?
Well, there is a longer answer as well. There's a few factors really, but generally we're finding the market was changing. Bigger industries are moving into the filament side of things. We still felt we produced really good quality filament, and I know.
I mean, you've seen the reviews on Filloween. Like you guys make good stuff.
Yeah, but the future of that is not something that I felt realistically, if we were being honest with ourselves, we'd be able to guarantee going forward and stay competitive. So it was all about making sure the business actually worked going forward without. There was one of two routes we could go. We could either make the business profitable and function and work at a sacrifice of the quality, which I wasn't prepared to do, or we just call it a day. Plus, the new business that we've moved into now is something that I just felt was so much. It was the real a passion drive for me. Like it's an area that I think we can really make a difference. And yeah, it's.
So what is that you're doing now? What is not the 3D printing, the Institute of 3D Printing? Yeah, what is the Institute of 3D Printing?
The Institute of 3D Printing. Sorry if it's a bit of a mouthful. Terrible branding. But essentially, without trying to give you a marketing spiel, it's an all-encompassing training suite for currently FDM 3D printing. It's not just a bundle of courses around 3D printing, but we do cover that. So we cover the top high-level theory. We take people through the very beginning, starts, number one, bed leveling, all the way through to different areas, slicer components, all the settings that you'd modify there, even through to orientation and those sorts of aspects, for aesthetics and strength. Everything's covered at the top level, and then we cover specific sections in real deep dives where we literally show you in the three popular slicers, not mentioning any names, but we'll show you in those exactly how you do each section in detail. Like you can't miss it.
And that's all going to be a paid service, a subscription membership kind of service, right?
Yeah. So for a low monthly fee, you get that. Free updates for life, but you also get extra content that we add in, each week, really, and also expert technical help that's unlimited.
One-on-one.
Yeah, one-on-one. So these guys that are on our team are literally work with people personally to get their printing profiles exactly tuned in.
And where can people find more info on that? Where can they find you?
So the short URL is just io3dp.com, and you'll find more information there. And so it's exciting. The early feedback's going well, and we're just going to go on to bigger and better, more content, really.
Interesting stuff. Thank you. Thank you, Rutger, for taking the time here at Ultimaker. You've got two new big things. You've got the Ultimaker S3 over there, which seems really incremental, but the big thing is the S5 upgrade. So can you tell us a bit about what's new and what these two add-ons are?
Yeah, of course I can tell you that. In the middle you see the Ultimaker S5 printer, which is in the market for over a year already. It has been successfully adopted by many companies and larger enterprises for more like the professional applications. And we have really looked into the needs and requirements of that specific target audience. And what we saw is that they want to spend as less time possible around the machine. They really want to use it for printing. That's why we have developed, for example, the material station, which is really focused to utilize the Ultimaker S5 printer. And on top you see the Ultimaker S5 Air Manager, which is in place to meet the latest requirements of an enterprise environment.
So the material station basically preloads material as you need it for the print, right? And it's also integrated into Cura. It shows up in there. It gives you the material list, right?
Absolutely, absolutely. And another benefit is, and I think that's very important to address, that it can automatically switch materials. So, for example, it addresses the end of filament anxiety that we faced in the market. Which is now, so if you run out of filament during a print, it will automatically continue to finalize your print.
That is a great feature, and I've also heard it does have some sort of humidity control built in.
That's correct. It keeps the filament in great condition due to the fact that the humidity will always stay below 40%, especially for countries that face high humidity and companies that operate in those areas. I think it's a great benefit that they now have a dehumidified way of keeping their filaments in great condition.
And the Air Manager actually has two features. So it has the filter and the fan, but it also does temperature control, right?
That is correct. So it locks the build chamber. And there are a few benefits coming from that. One is you can't put your hands anymore into the machine, so you avoid any risk of touching hot parts while the machine is in operation. Another thing is very important, that the Air Manager, the Ultimaker S5 Air Manager, is being managed by the Ultimaker S5 printer. And that basically means that it recognizes the material, so it knows the ideal temperature for the build chamber in order to print with. So if you print with a specific material that needs a specific temperature, that is taken into consideration for the airflow that the Air Manager generates.
Very nice. Okay, and on the topic of filaments and materials, let's move on to your wall of filaments back there. So behind us we have your wall of materials, right? And from what Ultimaker did in the past, where it was Ultimaker materials that were optimized for the machine, this seems like a bit of a bold move.
Yeah, so what we really try to achieve is one of our philosophies, is that we really want to enable as many materials as possible to offer to our users, because taken from the application side, you really want to find the material that suits the application best. And that's why we have unlocked the Material Alliance program in order to adopt as many materials for our printers as possible to achieve the applications that you're really aiming for.
So what does the user get when they use a material that is processed through that Material Alliance procedure? What do they get as a benefit?
The user, you mean? Yeah. So from a user perspective, you first of all you have plenty of choice, as we believe that you should have access to any material available in the market. So that is the first thing. The second thing is the materials are being optimized based on the print profiles, and from that sense you always get the best optimal result by the materials that are being offered in the marketplace that you adopt for the application you need it for.
So this is a program where the user buys one of these filaments and they can use a pre-tuned profile directly in Cura. They can download that and they get something that is approved and optimized by the filament manufacturer for the Ultimaker.
Yeah, so the print profiles are being delivered by the filament manufacturer, so to say. So they optimize the profile and you can download the profile and print with it.
Perfect. Thank you for your time.
Thank you.
Martin, people know Fillamentum for Rapunzel silver, for like your nice, sparkly, beautiful filaments. You guys know that, but you're also showing off some very functional materials today. For example, the vinyl 303. The one question that I have to start with, like, vinyl is toxic when you print it, right? It releases some pretty nasty fumes.
Yeah, definitely. Well, vinyl, as you know, it's a PVC. The standard community in the household pipes, tubings, and so on. There is a lots of hype around the toxicity of PVC today, and this material is focused on the heavy industry. We don't recommend it to hobbyists because you have to use an enclosed chamber printer with air ventilation, charcoal filters, HEPA filters, because the chlorine can be released, and that's really nasty. But some people and some companies need to print it.
And when you can actually print it with the proper safety precautions, it is heat and impact resistant, it is self-extinguishing, it's hard, it's basically, like property-wise, it's like an ABS, right?
Well, maybe, but the chemical resistance of the material is amazing. It's amazing. It's a really great material for chemical resistance. Also, the strength of the material hardness is great. And still, it's not could be switched to another material. It must be in PVC. Still, there are still application which still have to be in PVC.
So that's an industry only, but high performance material. What else do we have? I asked you about PVC being weather resistant and UV resistant. You've not tested that yet, but you do have ASA.
Yeah, definitely.
And you mentioned something that this is more resistant than some of the other ASAs.
Yeah, because ASA is resistant to or UV stable, but once you mix up the pigments, it can change the color. We have tested our material that can withstand 5 years, up to 5 years and more, with any change of color, brittleness or something else. So you won't crack it. We have a customer which use our material on racing boats. And he made boxes for GPS and electronics, and he was surprised how can our ASA withstand salty water and weather, rains on the boat, and great material for outdoor use.
Yeah. So ASA naturally, the base material is resistant against UV, but your addition is that it's going to stay the same color.
Yeah, the color.
Yeah.
The color stays same.
Fantastic. And there was one more material that we wanted to talk about, and that is the carbon fiber reinforced CPE. So let's move over there real quick.
Yeah.
So CPE CF112 carbon hardness 75 short D. That's probably more than the full name, right?
Yeah. Well, it's a CPE-based material which is filled with 12.5% of carbon fibers.
Okay. But that's not what's the CF112?
No. It's just a number. Yeah.
Okay.
It's a great material. It's based on CPE, which is improved PETG, enhanced by a few polymers, which increase chemical resistance, impact resistance, heat resistance. It can withstand 80 degrees Celsius for long term, easy printability.
That's what the fibers really help with, reducing warp and increasing adhesion even to a certain point, right?
Yeah, definitely. Also, the nice smooth surface.
Just hides any layer artifacts and stuff.
Yeah, definitely. And also you can play with the effect of the carbon fibers by layer height. If you increase the layer height, you get the more structure, smooth surface, which is can see here. It's the carbon fibers isn't too long because we have to get it through the nozzle, so they are about 100 microns long. So. The purpose of the material was for static improvement, static force, so pressure, hardness, not for the impact, because the carbon fibers for layer bonding is not so good.
Yeah. But you do actually promise an increased yield strength essentially for these parts.
Loads improvements, yeah, and also as it's based on CPE, so we have great CPE properties.
It gets a head start by being, PETG based or polyester based, essentially.
Yeah, definitely.
All right, very interesting stuff. Thank you for your time.
Thank you.
Martin, you're making the Bondtech extruders. I've actually not seen this one. You're telling me this one's been out for a while.
Yes, it has. It is a direct upgrade for the Ultimaker 2 Plus and the Ultimaker 3. So it's a drop-in replacement. We have made this project together with a guy called Christian Mattes in Germany.
So this is one of your upgrade kits, and I think this is the big one that we can talk about today. you've got so many upgrade kits that people can just plug and play onto their printers, up to being just a complete swap with everything you need. So I think that's this one, right?
Exactly. That is the new direct drive upgrade, complete extrusion system for the Creality CR10 printers. So what this comes with is a new hotend, an E3D V6 hotend, and then our feeding technology up here. And
so it's a BMG extruder basically, yeah? Geared dual drive.
Geared dual drive extruder, yes. It comes with a pancake motor to save weight and also still have the torque. What we also have here is that we have the part cooling here. We have a radial fan here. We have the part cooling fan duct here that really gives a good part cooling.
So this is essentially a plug-and-play upgrade for the CR10, you said, right?
That is
so
correct.
Everything, you take out the original extrusion system, put this in, you get a part cooling fan. You even have the wiring prepared for the CR10 to be compatible, right?
That is correct. We supply the wire that plugs directly inside the printer. So it's we also provide a customized firmware with the settings needed for this.
Very, very nice. We've got some more upgrades here. So I think one just went missing, one's over there. But these are Prusa upgrades. So these work a bit different because you don't get everything that you need, at least not with this one.
So what this basically is the upgrade for the Prusa MK3, MK2, MK3S. So what the main difference here is that we still use the same gearing, 3-to-1 gearing ratio that allows us to use the pancake stepper, the lighter pancake stepper. The advantage of that is, of course, reducing the weight, but it also gives higher resolution of the extrusion. What we have done here is that we have done a kit so the user can reuse the parts that they already have. So we deliver this one without the gears, and they are reuse it from the gears that they already have inside the printer.
And with this one, this is the E3D version, you also reuse your existing E3D V6. With that one, that uses a different hotend, right?
That is correct. We have many requests from the market, from guys talking to us. Could you please make a version for the Mosquito hotend? So we did it, and here it is. The Mosquito hotend from Slice Engineering.
Fits right in, and I assume you don't really need to do much firmware changes with this. Maybe the steps per millimeter, that's what's changing with the geared extruder, that's all.
Yeah, it depends also if you use a thermistor from Slice Engineering, because then it uses another ADC table, so you need to also modify that one. But we supply also the firmware for that one, so they are ready to download.
Another plug-and-play upgrade. All right, thank you for the update.
You're welcome, Tom.